Okay, today we're starting a new chapter. We're going to be solving some problems involving direct, inverse, joint, and combined variations. Today we're just doing the first three examples, and we'll finish everything up with part 2 video. There's our vocabulary. Go ahead and push pause and write them down. Okay, in chapter 2, you studied many types of linear functions. One special type of linear function is called a direct variation. If you remember, we had y equals mx plus b. b is the y-intercept. When b is 0, you just have y equals mx. That is your direct variation. Direct variation is a relationship between two variables, x and y, and we're actually going to use k now, so it's written in the form y equals kx. Poor planning of a space there. Y equals kx, where k can't be 0 because an x is 0 too, and you just have y. Doesn't matter. That doesn't make sense. In this relationship, k is the constant of variation. For the equation y equals kx, y varies directly as x. Okay, so you're going to hear a lot of problems. Something varies directly with something else. Okay, that's just how, whenever I read that sentence, something varies directly as something else, I write it left to right. Something varies directly with something else. Okay? A direct variation equation is a linear equation in the form y equals mx plus b. That's what I just talked about, where b is 0, and the constant of variation k is the slope of your line. Because b is 0, the graph of a direct variation always passes through the origin. Okay, it always, that's a beautiful straight line, right? Always passes through the origin because your y-intercept is 0. First example, given y varies directly as x, and y equals 27 when x equals 6, write the direct variation function. So here is what I write. Y varies directly as x. And k goes there. When y equals 27, x is 6. Solve for k. Get my calculator out, sorry. 27 divided by 6. K is 4.5. So our direct variation function is y equals 4.5 times x. Helpful hint, if k is positive in a direct variation, the value of y increases as the value of x increases. Your slope is positive. Okay, you try this one. Given y varies directly as x, then you put the k in, and y equals 6.5 when x equals 13, write in graph, write the direct variation function. Push pause. Sorry, that's the bell. Sorry about that, but that is your answer. Try another one. Okay, when you want to find specific values in a direct variation problem, you can solve for k and then use substitution, which is what I usually do. I go this way. Or you can use the proportion derived below. Sorry. I always just solve for k and then use substitution. But because for the first example you find a k, and for the second example you find a k, you can actually just use a proportion. We'll try both. The cost of an item in euros, which is E, varies directly as the cost of an item in dollars, D. So euros varies directly with dollars. So if I have 3.85 euros, $5, I can solve for k. 3.85 divided by 5, k is 0.77. So now we want to find d when euros equals 10. We're just going to use that equation. So we have, E equals 0.77 d. So 10 equals 0.77 d. I'm left with D equals 12.99. Okay, so that's the one method to do it. We're going to do it again. Choose the method you like and go with it. I usually work the problems this way, but it doesn't make it more right than the other. Okay, we're going to use a proportion. E1 over D1 equals E2 over D2. So if you go back to the problem, you have 3.85 over 5 equals 10 over D. At this point, we cross multiply. Get my pen out. Cross multiply, and I have D sub 2 times 3.85 equals 50. Divide both sides. D equals 12.99, which is what we got with method 1. Okay, you try one. Okay, the perimeter P of a rectangular dodecagon, there we go, dodecagon, varies directly as the side length S. And P equals 18 inches when S equals 1.5. Find S when P equals 75 inches. Read it again slowly, set up your proportion, and solve it. Okay, there's the first method. Push pause and check it out. Try using your proportion, see what method you like best. Exact same answer. Life is good. Let's move on. Okay, let's try some joint variations. A joint variation is a relationship among three variables that can be written in the form y equals kxz, where k is still the constant of variation. For the equation y equals kxz, y varies jointly as x and z. The phrases y varies directly as x and y is directly proportional to x have the same meaning. So remember, those are the words you're looking for, because a lot of these are going to be word problems. Y varies directly as x and y is directly proportional to x. Okay, let's try one of these joint variation problems. Let's read the problem. The volume V of a cone varies jointly as the area of the base B and the height h. So I have a constant in there. Okay, we know that volume equals 12 pi feet cubed when B equals 9 pi feet cubed and h equals 4 feet. Find B when V equals 24 pi feet cubed and h equals 9 feet. First we have to find K. So plug in everything you know. 12 pi equals K times 9 pi times 4. Okay, 9 times 4 is 36, so I'm going to go ahead and divide both sides by 36 pi. 36 pi. That cancels all that out. The pi's cancel, and you're left with 0.33, mistake, equals K. Okay, so we're going to use the variation function, which we just wrote, 0.33bh. And we're going to find B. This should be big B. Typo there. So volume equals 24 pi, 0.33b, and h equals 9 feet. Let's see, 0.33 times 9 is divided by 2 points, mistake, 2.97, divided by 2.97, 24 divided by 2.97, I have B equals 8.08 pi feet cubed. These cancel out here, and you're left with that. Okay, so we found our area of base B. Try one on your own. The lateral surface area L of a cone varies. L varies jointly as the area of the base, radius R, and the slant height L. So I just wrote the equation for you. Now go ahead and solve it. There we go. R equals 1.6 meters. That's all we have for today. Good job.